Hey guys, back for volumes, last bit of the volumes. So we have cones, we have pyramids, we have spheres to look at. So the volume of a cone. So I think of this like a cone kind of looks like a cylinder. Like it's like a cylinder, like but it's like you kind of chop off a bunch of it. And you remember the volume of a cylinder is pi r squared h. And the volume of a cone is 1/3 pi r squared h. So basically, remember what I said before, like this is like the base of the cylinder and that's the height. And so for a cone, it's the base times the height, like this, like it's the big base, capital B base. So this is, it's 1/3 times the times the base times the height. So it's 1/3 times the area of the circle times the height. So for a cone and a cylinder with the same radius and the same height, you could fit 3 of those cones inside that cylinder. That's basically what this is saying. So this is our new formula here. 1/3 pi r squared h. And we're going to use that in a minute here, but not immediately. So pyramids kind of look like cones. This is what I was saying in the previous video. The volume of a pyramid is like 1/3 times whatever the area of the base is times the height. Pyramids sometimes have bases that are square, sometimes have bases that are triangles, sometimes have bases that are hexagons, whatever. This is the area of the base. We haven't really seen any of these funny pyramids yet, but we will. Times the height times a third. Similarly, it's like the volume of a prism was the area of the base times the height, and the volume of a pyramid is 1/3 times the area of the base times the height. So it's like kind of an intersection between pyramids and cones and cylinders and prisms. But generally, for anything that's like pyramidally shaped, like a cone or a pyramid, it's 1/3 times the area of the base times the height. Yeah. So, right now the sphere. We actually already saw this formula because of the ridiculous mistake I made in the previous video. The volume of a sphere is 4/3 pi r cubed. I promise that's the volume of a sphere. I'm not going to go back and change that one. So, I honestly can't remember why I included this, but I think it's like it shows up in a problem later on. So I wanted you guys to have seen the word, a great circle. A great circle is like any circle that you, like when you cut a sphere with a plane, you get a circle. And the great circles are the biggest ones you can draw. Basically, when like the equator is a great circle, for example, on the Earth. Because if you like it's a circle that's like whose center is the center of the sphere. And great circles, it turns out, are the fastest ways to get from place to place on the Earth. They're like the shortest distances. I think the word for that is geodesic, but what that means is that sometimes when you fly from like here to Alaska, you end up going like you don't go straight across the country. You go like over the Arctic Circle. It's very strange, but so great circles, the biggest circles you can draw on a sphere, and their characteristic is that they share a center with the sphere. The center of the circle and center of the sphere are the same, unlike these circles where the centers are not the same as the center of the sphere. So, okay, so now we'll do a couple volume problems, and then we'll be done. So provide exact answers. Okay, so this is a pyramid. So the volume of a pyramid is 1/3 times the base times the height. Remember that capital B stands for the area of the base. It's not like a distance base, it's the area base. So this is kind of nice. They give me all that information. The area of the base of this is a rectangle, and so it's 5 times 11, which is 55. And the height is 10. So I'm going to have my volume is 1/3 times 55 times 10. Let's provide exact answers. Okay, that's 550 over 3 yards cubed. Remember, volumes cubed. That's fine. 550 over 3, as everyone knows, is 183 and 1/3. I guess you could write it as a mixed number or something if you wanted to, but it's probably the best way to write this answer. So the sphere here, the volume of a sphere is 4/3 pi r cubed. And the radius in this problem is conveniently half of 20.6, which is 10.3. Okay. So it's 4/3 pi times 10.3 cubed. I don't know why it says to provide exact answers here, but whatever. So this is when you use your calculator. 10.3 cubed is 1,092.727. That number times 4 is 4370.908. Over 3 pi. This is a terrible problem to provide an exact answer for. Let's pretend for a minute that this says round to the nearest tenth, or something. Because this is, I would never ask you to write this ridiculous answer this way. So let's just say it says round to the nearest tenth. So assuming that it said that, which it ought to, you would write your formula out like this. You'd plug in your numbers, then you just plug all this stuff into your calculator. You'd be like 4/3, you type in 4 divided by 3 times 10.3 cubed. That would give you, instead of the nearest tenth, that gives you 1457 pi. It's 1456.969, which is 1457 to the nearest tenth. And then it's feet cubed. So this one is not ridiculous to ask you for an exact answer for, but this one kind of is. So I think I would avoid doing that if that was a question. All right, find the volume of the cone. Right. Provide an exact answer. Okay. Sure. So volume of a cone is 1/3 pi r squared h. So I got the r, but I don't have the h. But I remember when I was finding surface areas that there's a way to find the height if you have, like I can draw this right triangle here like I did before. And it's a little frustrating. That number is 12. Let's change that number so that's 13, just to make our lives a little bit easier. Let's call that 13 instead of 12. So I don't know why I erased that. Let's say that's 13 centimeters and not 12. Okay, so please change that. Now I know the radius is 5, so it's 1/3 pi times r squared. 5 squared is 25. Now I got to find the height, and I can do it like I found the slant height before, but just rearranging the terms in the Pythagorean theorem. So I can say 5 squared plus h squared, this height I don't know, equals 13 squared. So h squared is 13 squared minus 5 squared. So I'm pretty sure it's 144, which means h is 12. So I got 1/3 pi times r squared times 12. 1/3 times 12 is 4. And 4 times 25 is 100. So it's 100 pi centimeters cubed. So it's pretty much just an application of this formula with the added little piece that you have to find the height with the Pythagorean theorem. So, all right. Last problem. a cone with a height of 10 inches and right. So this is how you find the volume of a frustum. That's what that word is, frustum. It's often mispronounced even by myself very regularly as frustrum, but it's not, it's frustum. So I don't know, looks like a lampshade maybe. That's probably what that is. I can call that a lampshade. The volume of the lampshade is what? So basically, I think the best way to think about it is to think about it like, they say this cone originally had a height of 10 and a base with 6, and then they cut it, like they chopped off the top of it. And so what's left is the frustum. That's what they want us to find the volume of. So basically, you take the original cone and you subtract the volume of the original cone and you subtract the volume of the piece that was chopped off, and what's left is this thing here. So basically, you had a cone and you like chopped off the top of it up here, like removed this top piece, and then what's left is this shape. So the original cone had a height of 10 and a base with radius 6. So we'll say the original volume is 1/3 pi r squared h, which is 1/3 pi. The radius was 6, so it's times 36. The height was 10. 36 divided by 3 is 12, times 10 is 120. So originally it was 120 pi inches cubed. And then the upper part is a cone with a height of 4 and a base with a radius of 2.4. Yeah, that makes sense. Okay. So I'll call that the removed volume. And that's 1/3 pi times that radius, it said was 2.4 squared. And that height was 4. And that is, and this is again what I just punched in the calculator, 1/3 times 2.4 squared times 4. I got, sorry, that 1/3 times 2.4 squared times 4, that's 7.68 pi inches cubed. And so the volume of whatever's left, remember, this is like kind of the part that I'm interested in right here. This is the part that we removed. So the volume of the frustum is the difference between these. Like if I take that away, I subtract the volume. So it's 120 pi minus 7.68 pi, which is 112.32 pi. Is that right? That makes 1320, yeah. And then inches cubed. So we've seen problems like that before where we like find areas by subtracting areas. This is the same idea. We find a volume by subtracting a volume. So that's it. I know this says homework, but the classwork is what is the fun problems. They are fun, I think. So hope this was helpful. Bye.